Hi guys. Okay, let's look at this problem that relates to titration. Now, I'm not going to go into the detail of the process of titration. I have explained that in one of my previous videos, so please refer it to that. However, we are going to learn to solve the problem, like the computation that is involved in this titration experiment, where we are trying to determine the molarity of oxalic acid. So we've taken 20 milliliters of oxalic acid in the pipette and we put it in the flask, and then we will determine the molarity of oxalic acid when we titrate it with the KMnO4 solution. The KMnO4 is 0.09113 molar, and the amount of this KMnO4 solution is used in neutralizing the oxalic acid is 23.24, and this piece is in the burette. So again, look for the process of titration in the other video or elsewhere on the internet, but let's look at how are we going to solve this problem. So first of all, important thing is when you are given milliliters, and these are the measurements. We take pipettes, it is in milliliter. The burette, that's, shows the readings in milliliters. So we always have to convert the milliliters to liters, okay? And the equality is 1000 milliliters equal to 1 liter. So when you convert it, you get 0.02324 liters of KMnO4 and 0.0200 liters of oxalic acid. Okay, leave that on one side. Secondly, there is a process of, or different steps, in which these calculations are done. Number one is, the molarity of KMnO4, the volume of KMnO4, and you can very easily find the moles of KMnO4 using the formula, or basically the transformation of a molarity formula. So that comes out to be moles is equal to mass into volume, the molarity into volume, okay? Not mass, I'm sorry. Next is, so you get the moles of KMnO4 that neutralized the oxalic acid. Now you will have to use the mole to mole ratio. That mole to mole ratio comes from the balanced equation, okay? So how many moles of oxalic acid got neutralized by the moles of KMnO4. Once you get the moles of oxalic acid, you divide them by the volume, and that's going to give you the molarity. So these three steps we are going to now conduct here. So number one is finding the moles of KMnO4. Actually, it's coming from the manganate ion, the permanganate ion they've given you. It's actually coming from KMnO4. Okay, moles of KMnO4. So that is the molarity times volume. And what was the molarity? Molarity is 0.0, right? 9113 molar times the volume is 0.02324 liters. Okay, so let's get these calculated. Give me a minute. Okay, so it comes out to be 0.00211 moles. Okay, so that is the moles of KMnO4. Next is we're going to find the moles of oxalic acid, which is H2C2O4. Okay, so that comes out using the mole to mole ratio. So we have 0.0021117 moles of KMnO4, or like your book is using just the MnO4, which is also fine. It's, it's coming from KMnO4. Okay, so KMnO4 and times now you are given the relation. This is in the equation, you see 2 moles versus 5 moles, and this is 6 moles, 10 moles, 2 moles, 8 moles. So we are only interested in the oxalic acid and the KMnO4, and that relationship is 5:2. So we see here 5 moles of H2 C2O4 oxalic acid over 2 moles of MnO4 negative, and I'm going to just put K here. Okay, so, okay, I'm just thinking, I don't want to confuse, this one was erased. So I don't want to confuse you. It's best just to put it as MnO4 negative, MnO4 and MnO4. Okay, I'm going to just take 1 minute, moles of MnO4 negative, MnO4 negative, and M moles of MnO4 negative. Okay, because that's what you see in the reaction. So I just brought it back to that. Okay, next is, let's do the calculations. Okay, so when we do the calculations, we get the moles of oxalic acid 0.005294. Okay, next is the last step, which is find the molarity of H2C2O4, okay, oxalic acid, and that is depending upon the moles of H2C2O4, that's the oxalic acid, over the volume of oxalic acid in liters, and that is H2C2O4. So here you have the moles 0.005294, okay, divided by the volume. We converted it 0.0200 liters, and let's do this, divide by 0.020 liters, and that gives you 0.2647 and 0.26. So this is 0.264 and you can just make it 0.26 molar. That is the molarity of the oxalic acid, C2H2O4 oxalic acid. Okay, so this is how you do these calculations. All right, thank you. Bye-bye.